The last video I made about this thing, I repaired a bunch of worn out pivot points in the boom, so that's all good to go. As far as I know, the only other major repair that it needs is to the undercarriage, which is completely worn out. Someone has put new tracks on it, but you can see the sprockets are totally worn out, and maybe you can see in here most of the rollers, or at least the bearings for the rollers, is totally gone. Also, it looks like the drive motor on this side has a pretty good hydraulic leak, I think is where that's coming from. So I'm going to, I guess, take the track off first and go from there. I did a few things off camera here. So the sprocket comes with threaded holes for some 1/2-inch threaded rods, I assume, to pull it off with. So I've got some rods threaded into those, and then I just faced off a piece of steel rod in the lathe and left some nubs on each end to help line things up. So that can go on there like that. And then this ram will go over it like that. And then I can cap it off with this thing I made. This is just 2 pieces of scrap 1-inch thick steel plate welded together, and then I welded this ring on it to help keep the ram centered, and drilled some 1/2-inch holes to correspond with these. So I'll go in like that, and then hopefully I can pull it off. That other puller was 12 tons. I think this is a 20-ton ram, so hopefully this will get it, because I don't really have another plan besides this. in my haste to pull that sprocket off, I somehow managed to pull off a pretty good chunk of the threads on the end of the shaft with it. Really hoping that's not a big deal, but for right now I'm just going to ignore it and continue on. So I decided I want to take the track frame completely off to address some wear on it. So I took this cover off the side here, and then there's a little cover inside there. It's that thing right there. I took that out, and that should make room to slide the drive motor out after you take the 4 bolts that hold it onto the track frame. I think that'll get that out of the way, and then there's this pin that acts as the parking brake. That will slide out as the track frame comes off, and then there's just 4 big bolts, 2 up there and 2 back here, that hold the track frame onto the rest of the machine. Alright, that's pretty much completely taken apart. So the first thing I want to work on is actually this tensioner pulley assembly. I need to take it apart so I can change the bearings in it. So I need to get this stub shaft that it rides on out of the fork, or whatever you call it. It's held in by a bolt on either side that runs through it. But the weird thing is I can't get the bolts out because there's no room at all to put a socket on either one of them. I'm really confused as to how they were installed, because the only thing I can think of is that the bolt head was taller and it was tightened down and then just ground off flush. But this one is actually, it sits just a little bit below the bore there. So I'm at a complete loss as to how those were put in. But I'm going to try to get them out by welding a nut to the top of them, kind of like that, and seeing if that'll grab enough to unscrew it. A bead of weld around the inside of this bearing so that hopefully I can catch it and force it out of there. got the track tensioner fork thing here. After I took it apart, I noticed that there's actually no threads in these holes that those bolts were in, so I probably could have just knocked them out with a punch, actually. But anyway, as you can see, it's pretty worn, more so on the bottom. See how it's kind of worn at an angle like that on each side, and then on the top it's also worn, not as bad, but just like that. So I've been thinking about it, and before I haul off and try to make a whole new one of these from scratch or something like that, honestly, no more accurate than this thing needs to be. I might be able to get away with just running some weld over it and machining it back flat. So I'm going to try that. That worked really good. Very happy with how that came out. As you saw, I welded over those holes, so I just drilled them back out after I faced it off. So now I'm going to do the same thing to the top side. The only difference being I made some plugs out of a piece of bar stock to go in these countersunk holes. That way I can weld over them without interruption, and then I'll just drill them back out afterward. That looks great. I went ahead and drilled the holes out. I'm not going to countersink them because since those threads are wiped out anyway, I'm just going to use roll pins to retain the idler shaft. I think that'll be fine. So the only other thing this thing needs is this egged out hole repaired. What I'm going to do is just take this piece of plate that I cut out and put it over it like that, and then weld it in from the other side and just kind of fill the hole up with weld, and then bore it out from this side and get it back around again. That looks good. It's nice and round again, and it's a little bit thicker, so there'll be a little bit more material for it to wear on next time. I got some new bearings, so I'm going to install those in the idler wheel so I can install it back in the fork here, and this will be ready to go, I think. made this little spacer to go in between the bearings. That way when I press the shaft in, both of the inner races will be supported and I won't be pressing against the bearing itself. Which, it doesn't show one of these on the parts breakdown, and there wasn't one in there, but it seemed like something it should have, so I went ahead and whipped one up real quick. So this shaft is just a loose fit in these bearings, and I thought there was something wrong with them, but they measure correct, and it's actually a loose fit in the old bearing as well. I just didn't realize it until I cleaned all the rust off. I don't think it's supposed to be like that. It doesn't make sense to me that it would be like that, because then the idler wheel could just slide back and forth on the shaft while you're driving around and wear it down. I don't know. I think it needs to be a press fit, so I'm actually just going to put this in the lathe, cut it down a little bit, weld it back up, and then lathe it down again to be a couple thousandths press fit into these bearings. Got it all welded up, so now I'm just going to turn it back down and not cut it undersize. I just drilled the holes in the fork out to the next size up to match the bigger hole in the axle there. This idler assembly is good to go. So next I'm going to work on this drive motor. As you can see here, it is seeping fluid out of the shaft seal area. But other than that, it seems like it was working fine. So I've got it all cleaned up here. I'm going to see if I can't just take it apart and reseal it, hopefully. I think I understand how this comes apart. It didn't look super complicated. Got this all taken apart. Everything looks pretty much immaculate, except for on the output shaft here, there is a little bit of corrosion. So it's actually got two seals. There's one that faces inward and keeps oil in, and then there's one a little higher that faces outward and keeps dirt out. And right on the edge of that outward facing seal is where it's kind of pitted, where I guess dirt was sitting and it corroded a little bit. But there's a polished area right below it there that the seal was riding on, and it looks fine. So I think it'll be okay to just put new seals in and put it back together. I'm pretty sure the reason it was leaking is the seals were just degraded and dried up. This was the main output shaft seal, and it tore pretty bad when I was pulling it out, and it's just kind of old and bad. Same thing for that exclusion seal, which is what that one is. And these O-rings that go in between the motor sections to seal them up are pretty dried out. So I got a seal kit. I'm just gonna put those in, put it back together, and I think that'll be fine. I went ahead and hooked this back up to the machine so that I can run it for a minute and make sure it's working right before I put the new seal guard on, because I don't think I can take it back apart without damaging the seal guard and having to get another one. Alright, that seems to be working just fine, so I'll come back and check it in a minute and make sure it's not leaking where it was before, and we should be good. I want to take this track frame off so that I can work on it along with the other one. So I took the track off, slid the tensioner out, and now I need to pull the sprocket off. I feel dumb because the whole time I was fighting with that other one, I completely forgot that I had this cylinder sitting around. I think this is a 50-ton cylinder, so if this doesn't pull it off, that'll just be ridiculous. Crud. This threaded rod just snapped right there at the plate, which I'm confused about because I was watching the gauge closely and it only had 2,000 psi on it, which is 10 tons. And I thought I put more than that on it with the other cylinder before. I don't know, maybe the other cylinder isn't a 20 ton. Or maybe I weakened it or something. I just watched a video of somebody taking one of these off with this exact gear puller. And all he did was max the puller out and then smack the face of the sprocket with a sledgehammer and it popped right off. So I'm gonna try that myself. I can't remember if I hit the face of the sprocket last time. I don't think I did. Or maybe it'll just pop right off. Well, what the heck? Okay. go. I've got both these track frames off and stripped down and all cleaned up, and I'm just kind of looking them over here. They don't look too terribly bad. On the back there are a few cracks. Let's see, there's one little one right there, and then one here. I think there were some on this one in the same spots. Pretty decent one right there, and a real small one right there. And if we come around to the front, it's worn about how you would expect right here, where the tensioner fork things slide back and forth. So like these rails on the bottom, hopefully you can see, are worn pretty decently right there on the front. And it's like that on both sides, more or less equally. This one's dished pretty good, so is that one. And then the sides are worn just a little bit. Not really very bad at all. Now, I had been thinking about this, and I was originally planning to completely cut out the whole rails and the plate that they are welded to under here, because that's actually totally worn out. I'll show you that in a minute. And then I was going to make new plates and weld them in and make it so I could bolt in new rails. That way they'd be easily replaceable for the next time they wore out. But I'm kind of having second thoughts about that. I've got these flipped over upside down so I can show you those plates. You can see how worn out they are from where the lugs on the inside of the track have come through and dug into them. Like I say, that's kind of why I thought it would be a good idea to replace these along with the rails and just do them both at the same time. But that is going to be a ton of work because it's welded all along here, and then the rails are welded right here, which makes it a lot harder, and they're welded back along here as well. If I can get these rails built up and squared off, I think I will just build these back up with some weld as well for the next time they're going to wear down. And you can see how the top rails here are worn a little bit, but they're worn very evenly, so I really don't have any intentions of doing anything to them. The other problem is some of these spots where the rollers mount are worn down. Like that one is worn pretty decent. That one's worn a little bit, but there's one right here that's really bad. This material is only a 1/4 inch thick to begin with, and that looks like it's worn about halfway through it, give or take, if I had to guess. It's worn about the same on that side, but this material is 3/8 thick, so it's not as big a deal. So I'm gonna have to figure out something to do about this. I think if I just tried to bolt a roller to that, it would probably crack pretty soon and create a bigger problem. I think I'm gonna try to build that area back up with weld. My only other option is to just cut out this whole piece and make a patch to weld in there, but there's very little metal left around it to weld a patch to. You can see it's worn all the way to what is the bottom edge here, and almost all the way to the sides because of how this is tapered like that. Anyway, I'm going to think a little bit more about this and bring you back when I have an update. Here's what I've got so far. I just did it exactly the same way as I did the tensioner fork thing. I just ran some beads of MIG weld on it to build it up, and then I snuck in here with a little 4-inch flap disc on an angle grinder, kind of like that, and ground it down as carefully as I could. And I don't think it's too bad, really. I put this little rule on it and held it flat against the unworn part on the back, and I mean, I think it looks pretty good. I'm not sure why it's sitting at an angle, but that's how the part in the back is, so maybe it was welded in there at an angle originally. I mean, I definitely wouldn't use the word precision to describe this, but I think it's probably precise enough for what I need. I got these all done, or as done as they're getting anyway. I had trouble getting the angle grinder, fitting it in here and kind of getting the angle on this that I wanted, so I ended up making a little adapter, or extension rather, and mounting the disc upside down and coming in underneath it like that. And that worked really well, except it would kind of randomly, like if you put too much pressure on the side, especially near the edge, the disc would catch and it would just shred all the little sandpaper pieces off the disc. That's one it happened to. I had that happen just like 3 or 4 times, I think. Yeah, it's probably not the safest, best thing to be doing on a regular basis, and I'm sure it's also really hard on the bearings and in the grinder too, so that's another reason to not really do that. But it did work well in this one instance. I also welded up these cracks, that one there, that one there. I just drilled a hole in the end of them and gouged them out with a die grinder, welded them up with the MIG welder, and sanded them back down smooth, trying to blend them in a little bit. Hopefully that will be okay. And then underneath, welded these frame horns up here, so that's got plenty of meat for it to wear back down again. And I just ran some beads along the bottoms of these here because they look like they were a little bit worn. I did the exact same thing to this frame. This was the one that had that one roller mount that was really worn out. So I welded up both sides of that to build it back up, and then just ground it down with the angle grinder kind of flat. But it was kind of lumpy and uneven still. Hopefully you can see how that one is. So I made up this quick little boring bar thing here with this mag drill and a piece of 5/8 round bar so that I can cut flat spots for the roller to sit, because I was worried that if I tried to just bolt it in, it would wiggle around and get loose again and then wallow out the bolt hole and stuff and just be a big mess. So I did the upper one already. You kind of see that worked pretty well, about as well as I expected it to. It's kind of a big cut to be taken with a skinny little boring bar like that, and a really kind of a flimsy setup. But I'm going to do the bottom one now and show you that. Hopefully I won't have to cut as deep on this one. I had to cut deeper than I thought I would on the top one to get it flat all the way around. That looks pretty good, I think. There's one little spot there that didn't quite clean up, but I'd have to cut it quite a bit deeper to cut that out, so I'm just going to leave it. I don't think it'll actually affect anything. Like say this side I had to cut a little bit deeper to get it all flat. Of course there's a lot of chatter on these, but that's to be expected. Like say it was just a 5/8 diameter bar, and then I think the bit was sticking out about 3/8 of an inch, so I would definitely never do that in any situation that I could avoid it, but these holes are 5/8 diameter nominal, so that's the biggest bar that I could fit through them. I went ahead and welded up and machined back down the worn surfaces on this tensioner fork, just like I did the other one right at the beginning. Unfortunately, after I did that and put it in here, I noticed that it was tilted pretty dramatically to one side. I guess that would be like the camber adjustment on a wheeled vehicle. And it was leaning out like that pretty bad, and I noticed it was because these rails up here are not both parallel with this flat surface that actually mounts to the machine. Maybe, I don't know if it's visible on the camera, but this rail is significantly higher than this one, and I'm not sure about the bottom ones. I think this one was slightly higher. I couldn't really tell. I couldn't think of a good reason for that to be that way other than just sloppy manufacturing, so I ended up compensating for it by cutting this side down more and then welding this side up more and cutting it down. And if I slide it in here, kind of like that, that's the fit I've got going on, which is not perfect, but it's much better than it was, for sure. And this side was the same, so I went back and reworked it, and this is how I've got it sitting in here. Looks pretty good, I think. Certainly a lot better than it was anyway. I think the last issue that I need to address before I can bolt all this stuff back together is this idler wheel, which is the one that I put new bearings in already, is unfortunately quite a bit smaller than the one on the other side. I guess the one on the other side is newer and not as worn down, which of course I didn't notice before I worked on it. So what I'm going to try to do to fix that is just build up this wheel with weld. That's probably not going to work very well because it is cast iron, and if you just try and weld on cast iron, it will virtually always crack right next to the weld. But I'm kind of holding out hope that it won't matter that much because it's a wheel, so the weld is always going to be in compression, so maybe the cracks won't matter that much. I don't know. I kind of see myself buying a new idler wheel in the near future, but before I do that, I'm going to try this. I'm going to try to weld this in relatively short sections and pause often to peen it with this hammer in the hopes that that will reduce the stress and prevent some of the cracking, which may or may not help. That's what that looks like so far. I guess now instead of being cast iron, it's hammer forged. Ha ha ha. Conveniently, I ran out of shielding gas right as I made it all the way around. So I've swapped the welder over to some old self-shielding flux core wire that I had lying around. And I'm gonna just continue on with that. Probably put, I don't know, maybe another layer or 3. I was trying to grind this down by hand, but it is not as round as I would like it to be. It's still kind of lumpy. So I've got it mounted in the spindle of this milling machine, and then I've got an angle grinder clamped in this vise, bolted to the table, and I'm going to try to maybe get a little bit more precision out of this setup instead of just doing it by hand. I did try to mount this in the lathe, but it's kind of too big. I don't know, I might could make it work if I really messed with it a lot, but it's also probably too hard to cut on the lathe anyway, so I'm going to try this first. It seems like it worked pretty well. It's definitely more concentric than it was. I am concerned because there are a bunch of cracks, like this one right here, that go through the face of the weld and run parallel to the radius. It look like they go right down into the original wheel, and they're just kind of scattered around. I'm not sure how many there are. There's a bunch of them. So I don't know, this thing might just disintegrate the first time I try to put a load on it. But worst case scenario, I end up buying a new wheel, which is what I was going to have to do in the first place. So if this lasts long enough for me to forget how much money I have sunk into this thing already, it will have served its purpose. These bottom rollers are all totally destroyed. See, the bearings are all out of them. and the flange in the middle is worn down to the point where the track lugs have worn into the body of the roller, or whatever part you would call that. They're all basically the same. This is probably the best one. It does still have bearings in it, but I think these are off the left-hand side. The ones on the right-hand side look virtually identical. So I went to the dealer and got 8 brand new track roller assemblies to the tune of not quite $1,900. They were $220 a piece plus tax. The only other source I could find for these was a Chinese company that made undercarriage parts for like virtually everything. They did advertise them for sale, but it was going to be $200 each after shipping and everything, and it was going to take at least a month and a half to get here. So of course I went with OEM parts from the local dealer. I made a little shim out of a washer to take up the slack from this hole where I faced it off and cut it a little bit oversized. I need to install this seal guard. I think it's supposed to be installed so that this flat face here is flush with this flat face on the motor. I'm not positive about that, and the instructions for it are really vague, but it should be fine either way. It's just a seal guard. It's not actually a seal. And the one that came out of it was all bent up. It looked like somebody just hammered it on there with a socket to no specific depth. So I just bored out a piece of plastic to make a little tool to drive it on there with. I'm going to install this new sprocket. The instructions in the parts manual say to clean the shaft off really well, but without using an abrasive. So I wire wheeled it, and then it says to wipe down the shaft and the bore and the sprocket with a solvent to degrease them. It actually specifically says to use alcohol for some reason, but I just use brake cleaner. I don't know why that would be a problem. And then just put the sprocket on the shaft. And then install a new nut and torque it to 275 foot-pounds. I'm sure that would probably be fine, but in the interest of keeping things overly complicated, I want to press the sprocket onto the shaft, mostly just because I can. So I made this little thread adapter so I can attach a threaded rod to the end of the motor shaft, like so. Let's see. Along with this hollow hydraulic ram. I'll want this just like that. Yeah. Oops, wait a minute. Forgot I need this on there. Okay. Put this. Turned around. I'm going to pump this up to about 10 tons because I think that's about how much that nut would apply at 275 foot-pounds. Yeah. Sorry. 4 tons, I think. What is this machine for? Okay, oh, this rod failed. Stretching that out. Okay. Man. I'm going to try this again with a piece of high-strength threaded rod that I actually bought because I thought I was going to need it to pull the sprocket off the other side. And then, of course, I didn't use it for that, but I'm going to try using it for this. This is just 1/2 inch, and the other rod was 5/8, but this is high strength, and the other rod was not. So this should take 10 tons, no problem. Well, I got it up to about 8 tons, so I guess that's just going to have to do. What the heck? As I mentioned, I need to torque this nut to 275 foot-pounds. My biggest torque wrench here only goes up to 250 foot-pounds, and you really shouldn't use a torque wrench at the extremes of its ranges anyway because it's less accurate. So I've got this tool here. This is a torque multiplier, and it's just a little gearbox, and for every 4 revolutions that you put in, you get 1 revolution out. So it increases the torque 4 times. Pretty filthy, but anyway. Oops. So I need to divide 275 by 4, 68 3/4. So we'll just do 69. That was easy. So the nut is right over the hole for the cotter pin, and the book says if that's the case, just tighten it until you can fit the cotter pin in. Oh. Nice. I'm gonna put some anti-seize on these rails for the tensioner because I'm worried they might try to gall. So hopefully some anti-seize will tide them over until a nice layer of rust and dirt can build up to lubricate it properly. Spring and guide rod back in. I also ended up just using bolts to hold the idler in because I was worried those roll pins, well, they're hardened, so I was worried that if they get like seized in there, it'd be a lot harder to get those out. With these, I can just weld to them or drill them out or whatever I need to do, which I can't do with the roll pins. Sorry. I got the other side all put back together exactly the same way, or almost exactly the same way. I did not weld up and machine down the shaft that the front idler rides on like I did on the other side, mostly because I ran out of welding gas, but also because I'm worried there might be a reason why it wasn't supposed to be a press fit. So this side is modified and this side is not, and we'll see if there's any difference. Probably not. But other than that, it's all the same. New sprocket, new nut. Now obviously there's a bunch of stuff hanging loose that I should button up, but I'm really eager to take it for a test drive just to kind of see how it rides now that it actually has wheels underneath it. So that's what I'm gonna do. Oh. What the heck? I guess this is as far as I'm making it for right now. It just turned off as though I turned the key off. It will crank, but there's no smoke coming out of the exhaust. So I think I'm just going to end this video here. It's plenty long enough. So until next time, thanks for watching.